Okay, hey guys. So this will be part 3 of network IP section. Um, I know I said in the last video, part 2, that I'll be covering calculations in that, but it turned out to be a long video, so I'll be doing calculations in this because it takes some time. So in network calculations, well, basically what we have is to in the A level syllabus, what we have is to subnet um, subnet a network into smaller networks. So as I talked before in part 2, a subnet mask is used to let the device, whether it's a computer, switch or router, know what the network portion is and what the host portion is. So again, a quick recap: in class A, the default the network ID is in the first octet, so the default um, subnet mask will be 255.0.0.0. In class B, both the first and second octets have network ID in it, so to mask it, it's the subnet mask will be 255.255.0.0. And in the third subnet third class C, all the first 3 octets have network information in it, so the subnet mask will be 255.255.255.0. So by subnetting, what we do is we take host bits to the network side. Okay, so let's take a well-known class C IP address, 192.168.1.40. Okay, so if this is the default address that is given to you all, /24, the slash notation is really important because we don't write the subnet mask. This represents the subnet mask. So if it's 24, that's 24 ones, which is 3 octets worth of ones. So that's the default in a class C IP address. So if we convert this to binary, let's say it's 128 plus 64 is 192.0.0.0.0.0. 168 is 128 plus 0 plus 32, that's 130, 160, 0, 8. So 0 and 1 and 40, 32, 0, 8. So this is the subnet mask, and this is the network address 192.168.1.40 in the dotted binary notation. So when you write the subnet mask, it's going to be 1111 1111 1111 1111 dot 1111 1111 dot 0.0.0.0.0. Okay, the reason for the 24 ones is because in a default class C address, the subnet mask will be 255.255.255.0. So by binary ending this, not binary ending, well, yeah, binary ending, binary ending this, you put, so you can separate the network ID of the given IP address. So what you do is you binary end them. So the network portion will remain the same and the host portion will be 0, right, when you binary end them, because so let's say 1 1 1 1 1 1 1 1 0 1, that's zeros, and this is going to be 1 0 1 0 1 0 0 0 0 0 0 0 0 0 0 1, and the other is going to be zeros. So this is how the device, be it a computer, router or switch, figures out the network ID from the IP address given and the subnet mask. So in order to increase the number of networks, what we do is we manipulate this subnet mask. Okay, so again yeah, so what we do is we take host bits and convert it to the network side. We take bits from the host area and we take it to the network side. So host bits, number of host bits reduce and number of network bits increase when we are subnetting. Okay, so to find out how many host bits we have to take to the network side, if you want if you want two networks, if you want the network to be broken down into two networks, what you do is you find out which 2 to the power number is equal to or greater than the number you want to break it down into. So in this case 2 is equal to 2 to the power 1. So this 1 right here, that's how many number of bits you need to take to the network side. So if you say you need 4 networks for, let's say, IT, finance, logistics and marketing, you need 4 networks. So you find out what 2 to the power number is equal to or greater than 4. So it's obviously 2 to the power 2. So you need 2 bits from the host side to take to the network side. Since a binary digit can be either 0 or 1. So this represents says 2 states, right? So 1 bit can show 2 states. So if it was 2 bits, it can show 4 states. That's how this method comes. So let's say you want 8. If you want 8, 2 to the power what number is 8? So 8 is equal to 2 to the power 3. So you need to take 3 bits. So let's say it's not exactly equal to 2 to the power number. So let's say it's 5. You need to make 5 networks, but you don't have a 2 to the power number being equal to 5, but you do have the closest number, which is 4. But if you break into 4 networks, you can't have 5 networks in it. So what you do is you break it down into 8. So you get 5 networks. Okay, you get 8 networks, you can use 5, but the problem is you have to discard 3 networks that way. So that's a disadvantage of subnetting. So if you have 5 network, if you need 5 networks, so 2 to the power n, there's no whole number for n which is equal to 5. So what we do is we go to the next biggest number, which is a 2 to the power. So it's 8. So 8 is equal to 2 to the power 3. So we need 3 bits to break the network into 5. You technically break it into 8 parts, but you only need 5. So 3 parts will be wasted. So yeah, so let's do a question. So let's take the last IP address we got, 192.168.40.1.40/24. So converting it into binary, it's 1000000. It's 101.0.1000 dot. Okay, so this is it converted into binary. So if we were to write the default subnet mask, it's going to be 24 zeros. So if we wanted to break this network break this big network into two smaller networks. So we want to break this into network A and network B. So what we're going to do is we have to find out which 2 to the power number is equal to 2. So it's obviously n is going to be equal to 1. So what we have to do is we have to take one bit out of the host portion. You take the leftmost bit. You don't take the rightmost bit. You take the leftmost bit and you take it towards the to the network side. So by doing that, what you change is the subnet mask. Okay, so you take one bit out of the subnet mask and 0 convert it into 1. So the new subnet mask will be 11111111 11111111 11111111 and 11000000. This is gonna be 1. So in decimal format, the subnet mask could be 255.255.255.128 because of this one right here. So because of this one, the network, this bit in the network side, in the host side, can be changed to either 0 or 1. So in network A, this part will be 0. All the parts will be 0. So it's a 1 1 0 0 0 0 0 0 1 0 1 0 1 0 0 0 0 0 0 0 0 0 0 1 dot 4 zeros. You know, that's the network ID for this network. But since we have broken it down, this part cannot change. Okay, so the highest number that this can go will be 7 ones. So this will be the same, this will still be 0, and this can go up to 1. So this will be the total range of the first subnet. See, okay, so we wanted to break this down into two networks. You found out which 2 to the power number is equal to or greater than 2, closest greater than 2. So n is equal to 1. So what you do is you take one bit out of the host part to the network side. So we did that. So the subnet mask changed to 255.255.255 and 128. Okay, so in the first subnet, everything is going to be 0, and it gives so the range again will be this 0 can't change because we have taken it to the network side, and this everything else can be become 1. So this is going to be the total range. Okay, so I talked about a network ID and a broadcast ID. Yes, so when we break a big network into smaller networks, each network will have a network ID and a broadcast ID. So if you have one network, there will be a network and a broadcast, which means two addresses which can't be given into devices. If you break it into two networks, there will be 4 addresses, two for each network, which can't be given into devices. If you break it into 4, there will be 8 addresses which can't be given into hosts. Okay, so like that. So once you pass this mark, the next address would be 1 here, right? 1 here and zeros on the others. That will be the start of network B. So when this bit, the bit you took towards the network side from the host side, changes to 1, that will be the start of the changes. That will be the start of the next network. So this will be 0.10101 000.000000001. So this will be the network ID of network B. So again, so when everything becomes 1, all the others become 1, that's going to be the broadcast ID of network B. So this bit right here, if we write the subnet mask, oops, you see this bit, you can change these without changing the network, but if you change this, the network changes. Okay, so from 0 to 127, so 7 bits, 7 ones is 127. So from 0, if you break it into two networks, from 0 to 127 will be network A, and from 128 to 255 will be network B. So the network, so the big network was broken down into two equal networks, network A and network B. Network A has its own network ID and broadcast ID. Network B has its own network ID and broadcast ID. So if someone were to ask the valid range of network A, since network each subnetwork has its own network ID and broadcast ID, so if you are asked the valid range of network A or the first network, you have to go by 192.168.1.1 to 192.168.1.126, because 127 is the broadcast ID of network A. And going on to network B or the second network, the network ID is 192.168.1.128, and the broadcast ID is 192.168.1.255. So the valid range of the second network will be 192.168.1.129. This one will come 1 to 192.168.1.254. Okay, so that's how you break down into two networks. So let me show you another one breaking down into 4 networks. So okay, let's do 5 networks because 4 is easy. So 5 networks, 2 to the power n. Okay, so n will become 3. N will become 3 because n can't be 2, then a network will be missing. So what you do is you take it to the next largest one. So that's 8. We break it into 8 when we take 3 bits. So 0 0 0 0 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. So there's 8 possible combinations here. So let's take the network as same as last one, 192, that's 1 1 0 0 0. So 0 0 dot 168, that's 1 0 1 0 1 0 0 0 dot 1, that's 0 0 0 0 0 0 0 1 dot it was 40, right? 1 0 1 0 0 0 shit 40 0 0 1 0 0 1 0 0. Okay, so this is our network address. So from the subnet mask, this is network ID, net ID, and subnet mask 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1. So oops, yeah, so this is the default subnet mask. So if we want to break it into 5 networks, we have to take 3 bits from the host side to the network side. So the subnet mask changes and the first 3 bits become ones and the others become 0. So these 5 bits you can use to have hosts, while the others belong to the network. So the first network will be binary ending 0 1 0 1 0 1 0 0 0 1 and 0 0 0 0 0 0 0 0. This will be the first network ID, and the first network broadcast ID will be keeping all these three bits which were taken into the host bit same. You put the others as 1. So this is the first network ID and the first network broadcast ID. And as this 0 changes to 1, keeping the other 2 intact, and the others become 0 again, this is the start of the second network. That's the start of the second network. Again, this one doesn't change, it comes down here, and when the others become 1, that's the end of the second network. And when this changes again, so the next one will be 0 1 0 1 1 1 1. So that's the start of the third network. And again, keeping that the same, keeping that the same, all 5 others changing to 1s, that's the end of the third network. Again changing 0 1 1 0 0 0 0 0, that's the start of the fourth network. And without changing these, when everything else changes to 1, that's the end of the fourth network. When this changes again to 1 0 0 and everything else to zeros, that's the start of the fifth network. And without changing this, when everything else becomes 1, that's the end of the fifth network. So we have had 5 networks so far, but you can have another 3 more, because you can change these 2 bits as well, but those networks will be a waste. But in the exam you still have to show it though, even though you need less number of networks. You have to, sometimes they ask, but sometimes they ask to write everything. So if you are to divide it into 8 subnets, you have to write all 8 subnets. So writing this down in decimal format, the first I will be writing just the fourth octet, because this is a class C IP address. The first 3 octets will be the same, because they are the network ID carrying octets. So they will be same in each and every IP address. I will be just writing the fourth octet. So in the first network, it will be 192.168.1.0 to 192.168.1.5 zeros. That's 5 ones. That's 31. Again, the next one starts with 32, goes on until 63. The next one starts with 64, goes on until 91. Next one starts with 92, goes on until 127. Next one starts with 128, goes on until um, 159, and then the next one will start at 160. It will go on until 191. The next one will start at 192, will go on until 223, and so on. So you see, when you take 3 bits, it breaks into 8 networks. 8 networks. So the number of IP addresses which you can have in these 8 networks, in each network you can find it out by you have 256 whole IP addresses in one octet, like 256 different numbers in one octet. So you divide it by either this number, you divide it by this number if you need 3. If you need 16 networks, you divide it by 16. If you need 4 networks, you divide it by 4. So then once you divide it, you can get a 64. You can use this number and you can get this answer clearly. So if we divided this network into 8 pieces, right? We needed 5, but we had to divide it into 8. So 256 divided by 8 is 32. So as you can see, each network has 32 numbers between it in it. So from 0 to 31, there's 32 numbers. From 32 to 63, there's 32 numbers. So each network has 32 IP addresses in it. Okay, so in this case, you only take 5 if you just want 5 networks, sub networks in that network, but you have to break it into 8 to get 5 networks, which will be a waste of 3 networks. Hope you guys understood. Just leave a question in the comments. If you all didn't understand, I'll do it again then. I'll be sharing a question for you all to do, and I'll be discussing it after you all do it. So cheers.